Okay, this is SAT Math section 20. In section 20, we're going to talk about measures of center, measures of spread, and shape of distributions. Now, that section title is a mouthful. It's also not all that helpful, especially when for many years you have been hearing about measures of center and measures of spread under different names. So let's talk about those different names that you're going to be more familiar with. We are talking about mean, median, and mode, and we are talking about range and variation and standard deviation. The measures of spread probably are a little less familiar to a lot of high school students, although at some point in your school math career, you probably have seen those terms. The first three terms, mean, median, mode, which are our measures of center, those should be very familiar to the vast majority of you. What is a measure of center? Well, we're going to talk about that in a moment. Let me just mention shapes of distributions, that last little part of this section name. We're talking mostly about how we represent data visually, for instance, in distribution curves, histograms, dot plots. We will get to those here as well. Let's talk about those measures of center. I'm going to go ahead and highlight these. A measure of center when it comes to data and statistics is a measurement, is a value that tells us what's typical in a set of values or what's going on in the middle of that data set. The most common or most maybe well-known of these three measures is, of course, the mean, which most of us when we think of average, we are thinking of the mean. These two terms, for all intents and purposes on this test, these two terms, mean and average, will be synonymous. Most students do know that when it comes to average, you just add up all of the numbers that you're dealing with and divide by the number of numbers. We'll write that formula, that definition down in a moment. So what is the mean? Again, the mean is something that hints at what's typical in a data set or what the data set's central value is. If we are told that there's a basketball player who scored 24 points per game last season, that tells us, again, what that player may have scored in a typical game. You do need to keep in mind that without additional information, we don't know if that player ever actually scored 24 points in any game. The player could have scored 23 and 25 points in every single game, and then every other game, let's say 23, then 25, then 23, then 25, and of course the mean would come out to 24. It's possible that this player could have scored 0 points in every other game and 48 points in every other game. So again, we don't know specifically how many points this player scored in any particular game. We would need other measures of center or measures of spread to help us home in on exactly what this player did in terms of scoring every game. But again, the 24 points gives us some sense of what a typical game might have looked like for this player. In terms of averages, obviously the first thing, and again, keep in mind every time I say average, I'm talking about the mean as well. In terms of average, probably the first thing that we should do is we should write down the definition, the formula. I'm going to go ahead and write down average. I'll put /mean over here, and we are going to write sum. I'm going to put a slash there and write total. You'll see why I'm doing that in a moment. I want that T there for total. Again, a little foreshadowing of what's to come. And we will do over number of things. Number of things, number of numbers that we added together to get that sum up there in the numerator. So again, average equals our sum over the number of things that we added together to get that sum. Everybody should be fairly familiar with that formula. In example 1 here, we are going to do what hopefully should be a very simple example. I definitely would recommend pausing the video and trying this example on your own, especially if you are already very familiar with averages and means. I am going to need my calculator for this, so let me bring that up. Okay, I'm going to go ahead and work through example 1 right now. So, table above shows the number of points earned by 3 students on 2 consecutive exams. Okay, first exam, second exam, number of points there in the table. What is the average increase in points earned? The average increase, so I'm going to circle that right now. Average increase earned from first exam to second exam. So we need the average increase. So what are we going to do? We're going to calculate the 3 increases. We're going to add them together. We're going to divide by 3. We're going to find the sum of the increases and divide by 3. That's what the formula that we just talked about is going to is going to have us do. So what is the increase from here to here? I'm going to put a minus here. Obviously, I'm doing 87 minus 78. That will represent the increase. So I'm going to do 87 minus 78, and I get 9. Obviously, we could do this without a calculator. We are, however, allowed to use a calculator, and on the test, all questions like this will show up in section 4, and therefore we will be allowed to use a calculator. And I've probably said in other videos that when you have the advantage of being able to use a calculator, yes, there are certain cases, like in the case of student C here, where we probably could more quickly in our head see that 95 minus 91 is 4. But I am a big fan of using the calculator even when calculations are very simple, mostly because one might help us avoid some careless mistakes. Although there always is the possibility you're going to punch something in the calculator incorrectly as well, so you got to be careful of that. And number 2, just to save some brain power. If we are allowed to have this, anywhere from $30 to $150 device do some work for us, we might as well let it do the work for us. So here, 98 minus 84, I know that's going to be 14, but I'm going to check it in the calculator anyway. See, there we go. 98 minus 84. And I get 14. So 9, 14, and 4, those are the 3 increases. The sum of those increases is going to be, let me add those up in the calculator, 9 plus 14 plus 4. And I get 27, so that's 27 over 3. I am going to go ahead and do that in my head. I don't need the calculator for that. So 27 divided by 3 is 9. That is the, let me just check here, average increase. Yes, that is the average increase. So on average, these students increased 9 points from their first exam to their second exam. Look at student B taking the lead there on the second exam. So that is example 1. That's an example of a question where we just got to calculate the mean in a very simple way. Most mean questions are not going to be that simple. They're going to be more complex. In fact, at the top of the next page, we're going to go ahead and talk about the ANT formula. What happens on a lot of mean questions is that the mean itself will be given, and instead of therefore having to calculate that mean, you'll have to use that mean to work backward from that mean to find something else. And in fact, most of the time what happens on these questions is, again, the average or the mean will be given. The number of things will be given. So these two things will be given, which means the missing piece will be the total. And because these questions are often set up like that, it becomes helpful, it becomes beneficial to know a rearrangement of the average formula. So remember the average formula that we talked about and that you've known for so long on the one on the previous page. We have average equals the total over number of things. Remember I said we want that T up there because it's going to make this little formula nice and neat and easy to remember. So if we were to multiply both sides of this equation by n, by the number of things, those n's will cancel and we will end up with a times n equals t. And again, that's a little bit more beneficial, a little bit more efficient, because if the average and the number of things are given and the total or the sum is the missing piece, it means that any time that we are given the average and the number, we will know, okay, I've just got to multiply the average and the number together and I will have my total, I will have that missing piece, and it's usually that total that is the key to solving these questions. Usually finding that total is going to be essential to solving these questions. So I'm going to go ahead and write down right here, average times number equals total. And again, the really nice, neat, easy way to remember this is I'm going to draw a little arrow here, a times n equals t, the ANT formula. So anytime we are given the average and the number of things, we should immediately consider, and probably will need to, multiply the average and the number of things together to find the total. Let's apply ANT on a couple of very straightforward questions here. And literally all we're going to do this time is apply ANT, and then we'll see a couple of questions that will look more like the ANT questions that you will see show up on the test. So in the following examples, we are going to use ANT to find the associated total or sum. That's what we are doing here in example 2. So example 2a says the average of 5 numbers is 28. So they tell us the average is 28. So that 28 is an A, that's an average. And that 28 average is made up of 5 numbers. So that's our n. That's our number of numbers that we've added together to get this average of 28. So when I'm doing n, I always like to write down a times n equals t, so I know where everything goes. I'm going to write 28 here. That's the average. I'm going to multiply that 28 by the number of things, the 5, and I am going to do that in the calculator so that I don't have to use any brain power. 28 times 5 equals 140. So what that 140 is that's the total, that's the sum of all 5 of these numbers. Keep in mind that 140 doesn't tell me anything about any individual number itself. It could be the case that one of the numbers here is, don't necessarily need to write this down, I'm just giving you a visual here, 1, 2, 3, 4. It could be the case that one number is 140 and the other 4 numbers are 0. Again, we have no idea from this total what any individual number is, but we do know that when these 5 numbers are added up, we get a total of 140. That's what the ANT formula allows us to do, find the total. Example 2b, the mean height of 6 first graders is 1.24 meters. So again, I've got mean is 1.24. I'm going to go ahead and write down ANT. Remember that A, average, and mean are synonymous. So the mean itself, the average, is 1.24. I'm going to use parentheses here. I don't want to mix that decimal with that multiplication dot. It's going to get a little bit confusing. So I'm just going to use parentheses, and then n, the number of, so that's a number, that's an average. The number that we're dealing with here is 6. There were 6 first graders that made up that average. So 1.24 times 6, so 1.24. I'm going to multiply that by 6, and I am going to get 7.44. 7.44 meters is going to be the total. So this was 140. This is 7.44 meters. So these 6 first graders, when you add up all of their heights, or when you stack these 6 first graders on top of each other, they're going to form a tower that is 7.44 meters high. Let's look at example 3, which is probably a little bit closer to the type of question we might see on the test. So in example 3, if you're getting the hang of this already and you feel like you want to do example 3 on your own, pause the video and do so, and then come back and join us. In example 3, we've got Dinesh earning 85, 95, 93, and 80 points on 4 exams that are each worth 100 points given so far this semester. How many points must he earn on the 5th exam, also worth 100 points, to average 90 points for the 5 exam given this semester? Okay, so we need how many points on 5th exam to average 90 points. That's what we need here. So again, on average questions, what I suggest is that you always look for opportunities to use ANT, and indeed, we can do that here because there's an average. That's the average that we need. There's the total number of exams, number, average. So we've got an A and an N that are both given, which means we can apply ANT here. I'll come back and deal with these first 4 given scores in a moment, but right now I'm going to do A times N equals T, and that is 90 times 5 equals, that's going to be 450, but again, I'm going to check it just to make sure, times 5 equals 450, yes it does. So let's just pause there, that 450, got to know what that means. That means that in order to get that 90-point average for the 5 exams, this dude Dinesh is going to need to get 450 total TTL points in order to get that 90-point average. Well, the thing is, the question is asking us what Dinesh needs on the 5th exam. We already know what Dinesh has on the first 4 exams. He's got an 85, 95, and so on. So what I'm going to do, I'm going to add up those 4 exam points. And what am I going to get? I'm going to get 85 plus 95 plus 93 plus 80. So Dinesh already has 353 points. He needs to get to 450 points. So how do we find out what he'll need on that 5th exam? We just subtract. We have a total for 4 tests. We have the total that we need for all 5 tests. So if I just subtract 353 from 450, I get 97. So Dinesh is going to need a 97 on his 5th exam to get from the point total that he has now after 4 tests to the point total that he will need after 5 tests to get that 90. So it is a 97 that will be the points he needs on the 5th exam. Dinesh better go get studying. That's a high score. A slightly even more complex example here. Example 4. Again, if you're getting the hang of it, pause the video, do example 4 on your own. Here we have in a class of 25 students, the average score of the 15 students who took the final exam on Tuesday was 80 points. So again, as you go through a question that you recognize as an average question, it would be a good idea to note where you might have some numbers. So there's a number of students, there's a number of students. You can see that this is an average here. We don't need to do anything with those values yet. We just need to sort of catalog what we've been given and realize that, okay, this might be one of those situations where we could use ANT. We have an average, we have a number of things, so ANT might be a possibility here. After the remaining students took the final exam on Thursday, the average score for the entire class increased to 83 points. What was the average score in points of the students who took the exam on Thursday? Okay, so average score, students, let's just do Thursday students, the average score of the Thursday students. So again, I already pretty much know I'm going to use ANT here, not only because, you know, we're in the ANT section of the manual, but also because I can see that I'm given some averages and numbers. So the first average that I'm given here is this 80 points. I'm going to put that in the average column. Again, always like to write down A times N equals T so that I know where everything's going to need to go. That 80 points corresponds to a number of 15. That's 15 students that made up that average. So if I do 80 times 15, I will get the total number of points that those 15 students scored. So that's 80 times 15. And what do I get? I get 1,200. So those 15 students amassed between them 1,200 points. Again, I don't know what any individual student scored, but I do know that if we add up all of their scores, we would get 1,200 points. Next, what do we got after the remaining students? Okay, so what does that mean? 25 students total, 15 students on Tuesday. So the remaining students, that's going to be 10, and that's another number. But do I want to use that 10 with this 83? No, I don't. This is important. It says the entire class's average was 83 points. So I don't want to use that 10 yet. I think I am going to use that in a minute, but I don't want to use that right now. This phrase that starts here and ends here says that for all 25 students, the entire class, the average was 83. So that's my next. I'm just going to have another row of anting here. So that's 83 times 25. So now I can get that, or I can find that the entire class amassed 2,075 points between them. So again, 15 students amassed 1,200. All 25 students amassed 2,075. Here's where that 10 students, that 10 remaining students that took the test on Thursday will come into play. I know that if when 15 students took the class, we had 1,200 points, and then when all 25 students took the class, we went up to 2,075 points. It must be the 10 students who took the class on Thursday that accounted for that increase in points. So here's what I'm going to do. I'm going to add a third row for anting. I know that for the 10 students, I have a total points of, let's do 2075. We're going to do minus 1,200. And I get 875. So I know that those 10 students amassed 875 points on Thursday. So to find the average, which is what the question is asking me for, I just have a little simple basic algebraic equation here. This is A times 10 equals 875. I'm going to do that over here. A times 10 equals 875. I'm going to write my intermediate steps, divide by 10, and I'm going to get A equals, it's going to be 87.5. When we divide by 10, we just move the decimal over 1, but I'm going to do it in the calculator just to be absolutely sure. And yes, 87.5. So the students who took the test on Thursday must have gotten an average score of 87.5 in order to amass that 875 points between them that took us from 1200 to 2075. That is a good example of how an ANT question might be posed, this example and the previous one with our good friend Dinesh. At the top of the next page, we need to talk about our next measure of center, the median. Most students do know that the median is the element or the value that lies in the middle of a sorted data set, a data set that is ordered. In fact, we're going to write that down right here. Let's write down median of a data set can be defined as middle value in an, I'm going to write ordered set. Sorted and ordered are synonymous here. In an ordered set. So very, very simple, silly example. If I had the set 2, 4, 9, so that is an ordered set. Obviously, if these were not in order, if I had, I don't know, 4, 2, 9, I need to reorder them. The 2 would go there, the 4 would go in the middle, the 9 would be the still the highest one. So my median is going to be the 4. The 4 lies in the middle, so that second position will contain the median, and that position contains a 4. So the median of that set is 4. If the set, however, notice that this set has an odd number of members, an odd number of elements. If the set, I'm going to write down, if set has an even number of, I'm going to write members. And again, when I say members, I sometimes interchange that with elements. It just means the things that are in the set. I'm going to move this over. If the set has an even number of members, let's write median will be the average or mean of the middle 2 members or numbers. So for instance, if I had the set 2, 4, 8, 6, the median would not be the average of 4 and 8. Why? Because this is not ordered. So what I would do is I would order it 2, 4, 6, and 8. Who do we appreciate? So I've got a 4 and a 6 in the middle. They are my 2 middle elements. I'm going to add them together, divide by 2, and get 5. So 5 would be the median of this set with an even number of members. Let's take a look at number 5, which is a, as all these examples are, a great example of what we might see when it comes to medians on the test. I am going to keep my calculator here. I'm definitely going to need it on this question. If you want to go ahead and try this on your own, go ahead. It is going to involve the ANT process that we just learned. Hint, hint. In example 5, we have the table above lists the yield in grams of substance X for the first 4 trials of an experiment. After the 5th trial, the mean yield of substance X for the 5 trials was 7.386. So mean was 7.386. So that's an average right there. And we have a number of things right there. So as I mentioned, we are going to be using ANT here. They want the median yield for all 5 trials. So here's what I'm going to do. I am going to use the ANT first. What I want to do is I'm going to write down A times N equals T. The average for all 5 trials is 7.386. I'm going to multiply that by the number of trials, and I'm going to get the total. You will see why we are doing this in a moment. So I've got 7.386. I'm going to multiply that by 5, and I end up with 36.93, and that is a number of grams, and of course that's the number of grams that I would get if I added up all of the yields from all 5. Remember, there's a 5th yield over here that I don't know. This 36.93 would be the sum of all of the yields. Well, I already have 4 of the yields. 1, 2, 3, 4 are given. So what I'm going to do is I'm going to add those up as quickly as humanly possible. I've got to be very careful here. It's a little tricky to type these in. So that's 7.398 plus 7.309 plus 7.421, 7.421, and then finally plus 7.421, 7.379. And the sum after the 4 trials, these 4 trials, they add up to 29.507. So that means the 5th trial, this is similar to what we did on the preceding questions, the 5th trial must account for the jump from 29.507, which is the sum of the 4 trials, to 36.93, which is the sum of all 5 trials. So what I'm going to do is I'm going to do 36.93, and I'm going to subtract my 29.507 value. So that's 7. So now I have my 5th yield, 7.423. They are asking me for the median yield. So now this is as simple as reordering. Are they in order? No, they're not in order. So I do need to reorder these. So I will go from least to greatest, although it doesn't really matter. I could go from greatest to least. And as I reorder, again, I'm going to cross these off. So it looks like, again, you got to be careful with these decimals here. It looks like that 7.309 is the smallest. And then what would be next? 7.379 will be next. And then the next one will be 7.398. 7.398. There is no need to keep going. I know that since I have 5 elements here, 5 values, the third one is going to be in the middle. There's the first, second, third, fourth, fifth. So the median will occupy that middle or third position. So 7.398 is indeed the median yield for the 5 trials. So good example of a question where a couple of our measures of center are integrated. They both play a role here, and obviously it will be the case on some median questions that you may have to use ANT. Often when medians are tested, we will see some information about frequencies, and this can be a little bit tricky because I'm going to give a little separate example over here. You know, if I have the numbers 2, 5, 9, 3, actually, let me do these in order to make it simpler. 2, 5, 9, 13, 15. Again, quick visual inspection tells me that that 9 is in the middle. And of course, that 9 splits the set into a lower half and an upper half, right? There's 5 total numbers. The 9 is in the middle. 2 of the numbers must be above, and 2 of the numbers must be below that 9. And then the 9 itself, I guess, would be the in the third position. That's the 5th number. But again, 5 total numbers, 9's in the middle, 2 above, 2 below. However, if I integrate frequencies into this question, and I say, for instance, I'm going to make this really simple. I say that there are 100 2's and 1 of each of these. Well, now it's a very different situation. Now, if I were to list all of these out, which I'm not going to do because it's 104 numbers and I'm not going to waste that time, but if I were to list all of these out, I would just have 100 2's in a row, and then at the very end, I would have this 5, this 9, this 13, and this 15, which means clearly the median is going to be the 2. Either there's going to be a 2 right smack dab in the middle, or in this case, since there's an even number of elements, there's 104 elements, there's going to be 2 2's in the middle, and we would take the average of those 2 2's and get a 2. So the point is that you've got to take into account frequencies if they are given, if you are trying to find a median. You cannot ignore the frequencies. You can't just look at this list of 5 values and say 9's in the middle, so that's the median. You have to take into account the fact that these values are occurring a certain number of times that will affect the median. The trick on these questions, the thing that can be slightly difficult, is trying to find that split point, that middle point. In other words, the position where the median lies. In the case of 3 numbers or 4 numbers or 5 numbers, again, quick visual inspection will tell you where your median lies. Here it was there's the middle position. It's the third position. Again, 5 numbers, middle position is the third position. But if you had a huge list of numbers where each number was occurring with a very large frequency, it can be very difficult to find the middle point, not to mention the fact that you're not going to want to list all of the numbers out because it's going to take you way too long. So what we do when it comes to medians and frequencies is we have to either intuitively know how to find the middle position of the set, or we have to have some little hints that we can memorize that will allow us to find the middle of the set. And that's what we're going to do here. We are going to memorize a couple of rules that will allow us to calculate where the middle position, where that split point is, where the median will lie and the set will be split into a larger and a smaller half. Again, there are intuitive ways to figure this out, and if you tend to do these questions with those intuitive ways, that's fine. I would still suggest knowing these little hints. So, to find the position of the median, in other words, that split point, that middle point, in a set with n elements, where n is, let's start off with odd. So if you have a set with an odd number of elements, then you are going to need to know that the median will occupy the n plus 1 over 2 position. Alternatively, you could do, I'll just write down, or n over 2, and you could just round up. And again, if you look at the 5 numbers here, so if n is 5, and remember n is the number of elements that you have, if you do 5, the number of elements that you have, plus 1, that's what we're doing right here, over 2, you get 3, and indeed, that's the position. It's not the value of the median, it's the position of the median. The median will lie in the 3rd position. Now, if the number of elements in the set is even, the median will lie, in other words, it will be the, let's do this. Let's do, the median will lie between, you know what, here I'll put, it'll be the average of the n over 2 and n over 2 plus 1 positions. And again, I can use this set here. I'll add another number here. I'll add like a 16. So if we find n over 2, so now there's 6 elements in the set, so n is 6. So if I do 6 over 2, that equals 3. And then if I take that n over 2 and I add 1 to it, I get 4. So my median is going to be the average of the elements in the 3rd and 4th position, which means I would average the 9 and the 13. That's the 3rd position. That's the 4th position. 9 plus 13 is 22 divided by 2, and I would get 11. So my median, again, would be the average of the elements or numbers in the 3rd and 4th position. Again, I would strongly suggest memorizing these rules. You are quite likely to see a median question that involves frequencies. They show up very often. Knowing these hints will save you a lot of time and a lot of effort. Let's take a look at example 6. Here we are given a set with a certain number of ordered elements, 379, 94, and we need to know where the median will lie. We need to know or determine the elements in which position will be or will determine the median. So this is an odd number of elements, so we follow the odd rule. What we do is we do 379 plus 1. We add 1 to that number of elements, and then we divide by 2. That is 380 over 2. I am going to do that in the calculator. It should be 190, but I would like to confirm 380 divided by 2, and I get 190. That means that I'm going to write it like this, 190th. That's going to be the position. Remember, that's not the value of the median. That's going to be the position in which the median lies. So whatever element in this ordered set lies in the 190th position, that element itself is going to be my median. We're going to see an example in a moment where we actually incorporate some values and some frequencies and see how we would determine what element lies in that position. 94 elements. Oh, by the way, again, we could do 379 divided by 2 and round up. And of course, 379 divided by 2 is going to be 189.5. Let's just do that. 189.5, we could then round up to 190. Either way, doesn't really matter. 94 elements is an even number of elements. So we're using this second rule here, this even rule. So we're going to do 94 divided by 2, right? That's n divided by 2. And what am I going to get there? 94 divided by 2. And I get 47. And remember, all we do is we add 1 to that 47, and we get 48. So the median is going to be the average of the elements that lie in the 47th and 48th position. If we can find those two elements, we add them together, divide by 2, and we would have our value of the median. So that's how we locate the split point. We just use these little hints and things become hopefully quite simple. At the top of the next page, we're going to take a look at a median question that incorporates some frequencies. So again, just want to point out one more time that the unfortunately very careless mistake that students make on questions that ask about medians is they immediately just go to the middle number. So they see, these numbers over here, they see that 5 is in the middle, and they think, okay, 5 must be the median. And on a question that involves frequencies, that's almost never going to be the case, that you will just have to pick out the middle number. Almost certainly you will need to use the frequencies. So here's how we do this. If you want to take a stab at the question, pause it and come back and join us. Example 7 says, when a college student uploads an essay to her class website, software on the website analyzes the essay and reports that the total word count is 821. It also reports the letter count of each word in the essay. Oh, God, it's a lot of surveillance here. As summarized in the table above, what is the median letter count of the words in the essay? So we need median, I'm going to circle all that. Median letter count, that's ugly. Median letter count of the words in the essay. So here's how we're going to do this. First of all, we're going to look at that 821. 821 is an odd number of words. So if we were to list out, for instance, let's say there's a bunch of 2-letter words. So we had like 2, 2, 2, blah, blah, blah. And then maybe some 3-letter words, 3, 3, 3, blah, blah, blah. And then we have our 4-letter words, 4, 4, 4, blah, 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 and 5s. So basically there would be 821. So obviously these are the less than 4, and there's the 4s, there's the 5s, and then all the way over there we'd have the greater than 6s. We would list out 821 numbers that represent all the letter counts in these words, and clearly we don't want to do that. So in order to find the median, the first thing that we want to do is we want to find that split point. So I'm going to do, since 821 is odd, I'm going to do 821. I'm just going to do the divided by 2 and round up here. So 821 divided by 2, I'm going to go into the calculator. I'm going to do 821 divide by 2, and I get 410.5. So that rounds to, here, I'll do this. That rounds to 411. So what that 411 tells me is that if I were to list out all of these letter counts of all of these words in this essay, all 821 words, the 411th number that I write is going to be the median. That's the position where the median lies. So what do I do with that information? Well, I'm gonna do this visually, since for some of you this is the first time you're seeing this process. So what I know is that for the less than 4 letters, there are 262 of those words. So that means, maybe there's a bunch of 1s and a bunch of 2s and a bunch of 3s. But either way, that would take me up to the 262nd number that I list. And then I get my 4s, and that's another 193 words. So what I'm going to do there, to find out what position the 4s end at, I'm going to add 262 to 193, and I'm going to get 455. So the word in that position, the last 4-letter word, the last 4 that we write, is going to be in the 455th position. Well, I'm done. I don't have to keep going. I know that the 411th position is going to fall somewhere between the 262nd position and the 455th position. Maybe it's going to be like right here, but it doesn't matter exactly where it falls. I know that a 4 is going to occupy that position. And even if there were an even number of elements here, and let's say we were between the 411th and 412th position, well, again, there would still be 2 4s in those 2 positions, which means we'd average those 2 4s and get 4, and we'd still have a 4 as the median. So I have just figured out the answer to the question. The median letter count has to be 4, because again, I know that the 4, one of the 4s that I were or would write if I were to list all of these numbers out, one of those 4s would occupy the 411th position. That is how we use the hints that we learned on the previous page to find the split point. And then, of course, we have to use the information that we are given about the values in the data set and the frequency of those values to find out what value is going to lie in the split point. Characteristics of or changes to a set and the effect on the median. Okay, this is possibly going to be slightly complicated. So one of the benefits so every statistical measure is going to have certain benefits and disadvantages. One of the benefits that a median has over, let's say, the mean is that a median is not susceptible to outliers. Outliers are, so let's actually highlight this, values that are very high above or very low below, very far above or very far below most of the other values in a set. So if I had, 2, 3, 7, 10, and then all of a sudden I had, let's say 1 million. I'm not going to put commas in there because it's going to get confusing. So 2, 3, 7, 10, 1 million. Well, the 7 is still the median. It doesn't matter how big that number all the way at the right gets. It wouldn't matter how small this number all the way to the left gets. That 2 could have been negative 10 billion. The median is still going to be 7, and there are some situations where it is beneficial to have a statistical measure that is not affected by numbers that don't seem to match the sort of the pattern of all of the other numbers or the clustering of all the other numbers. Now, when it comes to medians, it is important to understand that if we change values that are to the left of the median by making them smaller, or we change values that are to the right of the median by making them bigger, we are not going to affect our median. The only way that the median would be affected is if we took one of the numbers that were smaller and made it bigger, and in doing so crossed over the median, or took one of the values that was bigger and made it smaller in a way that crossed over the median. So for instance, if instead of 2, 3, 7, 10, 1 million, I had 3, 7, 10, 11, in other words, that 2 has become an 11, and then I have the million out there, now the median has been affected. Instead of the median being 7, my median is now 10 because, again, the 2 moved to the right of the median, and now the 10 is in the middle position with the 3 and the 7 below the 10 and the 11 and the 1 million to the right of the 10. Every now and then, College Board may ask a question that requires you to understand some of this. So let's try to get through example 8 as quickly as humanly possible here. If you want to try this on your own, obviously go ahead and do that. RX scores on 22 quizzes, each worth 20 points, are summarized in the dot plot above. Okay, this is a dot plot. We're going to go over these in a little bit more detail later, but it shouldn't be too hard to see what's going on here. Each dot represents a certain score. So for instance, this score of 14 right here, RX got 3 of those. Each dot is a score of 14. The score of 0 was on a quiz given on a day RX was absent. Oh, RX playing hooky. RX teacher will allow him to make up that quiz at a later date. Oh, that's nice. And will replace the 0 with his score on the makeup quiz. Very generous. What is RX's current median quiz score according to the dot plot? So we need the current median. So let's do that first. So how are we going to do this? I suppose we could just, sort of go visually through this and somehow try to find the middle point visually. But the way that we're going to do is we're going to use the hint that we already learned. We're going to take that 22, we're going to divide by 2, we're going to get 11. This is an even number, so our median is going to be between the 11th and 12th. It's going to be the average of the data points of the quiz scores in this case in the 11th and 12th position. So what I'm going to do, I'm going to do this. I'm just going to count until I get to that 11, 12 point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's the 11th guy or girl. So that's the 11th, which means the 12th is going to be in this column. It doesn't matter whether I do the top one or the bottom one. I'll just do the top randomly. So that will be the 12th, and then 13th, 14th, 15th, and so on and so forth. So this set is going to be split between a lower half and an upper half according to these two scores, which means the median will be the average of those two scores. The median will lie, in other words, exactly between this 16 and this 18, and the number that lies exactly between 16 and 18 is, of course, 17. So RX's current median quiz score, according to this dot plot, is 17. Now, 8b says if the teacher drops RX current highest and lowest score, what will be his median score? So here's the thing. All that's going to happen is we're going to get rid of one to the left and one to the right, right? The lowest and the highest score. The median's not going to change. If I have something like 2, 3, 7, 9, and 13, the 7's the median. Well, if I now have 2 items below and 2 items above that split point, that median, and I get rid of one of the 2 below and one of the 2 above, the set still remains balanced. In other words, the 7 is still in the middle. So getting rid of an equal number of members below and above the median is not going to affect the value of the median. So my median is still 17. I'm going to get rid of those slashes so I don't get confused. If RX score on the makeup quiz is 15. So if RX scores 15 points on the makeup quiz, what will be his median score? Okay, so that 0 is going to become a 15. Well, remember, that was the 11th position initially. If this 0 goes up to that 15, in other words, I get rid of that point and I move that point to here, it's not going to change the fact that this is still my 11th score, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I still have that 16 in the 11th position and that 18 in the 12th position. So I raised the 0 score to 15, but notice I did not cross over the median. That 0 did not go to a score that was to the right of the median, which means, again, my median's not going to change. Now, in example 8D, we might start seeing some changes. Hint, hint. If RX scores 18 points on the makeup quiz, what will be his median score? Okay, so now that 0 is going to 18. So what happens here is this is no longer going to be the 11th item because I know that you probably don't want to white out your dots, but I'm going to get rid of that dot there. And by the way, this one needs to go too because that was from a previous example. I'm going to put another dot here. So now I should only have these over here are only going to account for 10 dots, right? There's still 22 quizzes. That 0 just became another score. There's still 22 quizzes. So my median is still going to lie between the 11th and 12th, or be the average of the 11th and 12th quiz score. But now I've only got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over here, which means now my 11th and 12th are both going to be in that column of dots above the 18, which means now my median is going to be 18. So that 0 crossed over the median. The 0 got bigger in such a way that it crossed over the median, and indeed my median was affected. And then in example 8E, same thing's going to happen here. If I take that 0 and I go up even more to 20, the median will still be 18 because, again, I will still be left with only 10 scores over here now, which means once again my 11th score will be here, and my 12, actually technically, yeah, let me get rid of that. So the 0 becomes a 20. So now the 11th and 12th will be these two scores, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 11th and 12th will be these two scores here, and my median will once again be 18. So it is important to understand how changes to certain numbers in a set might affect the value of the median. We've got one more tiny little thing to do, and then we will wrap this section up. The mode is very simple. It is not common, very rare that you will see questions that involve modes, and if you do, you probably will be fine just knowing the definition. The definition of the mode of a data set is the most common, in other words, the most frequent, frequent value in a data set. So folks, those are our measures of center, mean, median, mode. Definitely want to know the little ANT shortcut, the little ANT formula. Definitely going to need to know about medians and what happens when they combine with frequencies, how to find that split point. And yes, should keep in mind the definition of mode just in case a mode question shows up. That's pretty much all you'll need to know to get through questions that involve mode.